Let's try some more practice going from an electron configuration to an orbital diagram. Let's take iron, for example. We'll write out its electron configuration. From this electron configuration, we're going to write or draw the orbital diagram. We'll go one sub-level at a time. Let's first focus on the beginning, the 1s sublevel. And I recall that S equals 1 box. Looking at my electron configuration, the exponent on 1s is 2, so there are a total of 2 electrons inside of our 1s orbital. So we're going to draw one up arrow and one down arrow. Remember, if we have 2 electrons in the same orbital, one will be pointing up, one will be pointing down. Now to the next sublevel in our electron configuration, the 2s sublevel. S equals 1 box, so we'll draw 1 box and label it 2s. The exponent on 2s is 2, so I'm going to draw 2 arrows inside of 2s. But again, I remember 1 up and 1 down. The next sublevel is 2p. I recall that p is represented with 3 connected boxes. There are 6 electrons inside of the 2p sublevel. Again, looking at that exponent on 2p. So we're going to draw 6 arrows. But please watch carefully the order in which I fill in the p sublevel. Remember that rule. Every box must contain 1 arrow before any box can get a second arrow. So in this order, we're going to go up, up, up. So I have 1, 2, 3 so far, and so my downs would be 4, 5, and 6 electrons. On to the next sublevel. Now we're at 3s. S is represented with 1 box. The exponent on 3s is 2, so that tells me 2 electrons, 1 up and 1 down. Moving on to the next sublevel, we have 3p. P is represented with 3 connected boxes. Label that 3p. And now looking at the exponent, there are 6 electrons total in the 3p sublevel. I have to fill them in this order. Up, 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 then down, down, down. Total of 6 electrons. My next sublevel is 4s. S is 1 box. 2 electrons go inside of this 4s. 1 up and 1 down. Then finally, I reach the last sublevel in our electron configuration, and that's 3d. Recall, D gets 5 connected boxes. Five boxes for 3d, and looking at the exponent on 3d inside of our electron configuration, it's 6. So I have to draw a total of 6 arrows for 6 electrons. But in the same manner that I filled in the p sublevel, d sublevel has to be 1 up arrow per box before any box gets a down arrow. So we're going to go up, 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 up. So I have 1, 2, 3, 4, 5. And so the 6th electron will be the down arrow in the first box. There you have it. We just drew the orbital diagram for iron. One thing that you can do to double check your answer, just use your electron configuration to make sure you have the correct number of arrows inside of each box. So if I'm looking at 1s, I should have 2 electrons inside of 1s, and I do have 2 arrows, so that's check. When I go and look at 2s, I should have 2 electrons total, and I do. Check. For 2p, I should have 6 electrons total. I do. Check. For 3s, 2. We're good. For 3p, we should have 6 total, and we do. Check. 4s, I should have 2. We're good. And then for 3d, I should have a total of 6. We do. And we have filled them in the correct order. 1 up arrow per box before we go back and do any downs.